So in this connection, we are going to learn about density of the unit cell, right? Molar mass of a compound. Let the molar mass of a compound is capital M. So in this molar mass, how many particles are present? That is, Avogadro number of particles are present. Therefore, Na, that is Avogadro's number of particles present in M. Yes, in unit cell, how many particles are present? In unit cell, right? Z number of particles possess mass are present M, nothing but possess mass how much? Cross multiplication, that is Z into M by Na. Now come to density, very well known about by you. The density is, therefore, density is equal to volume of mass by volume. Mass by volume. Mass of unit cell by mass of unit cell over volume of unit cell. Right? Therefore, density either denoted by rho or d, that is your choice, no problem at all. As mass of unit cell is, this is the mass of unit cell, that is Z into M by Na into volume, 1 by volume, 1 by AQ. This is the formula we are going to use and calculate any one of the variables when others are known. How many terms are there? D, density of the crystal or unit cell. Z is number of atoms per unit cell, already discussed in the previous case. M, molar mass of the crystal given in the problem. Na, Avogadro number fixed like your birth date, like that is 6.022 into 10 to the power 23 particles. A is to be given in picometers, nanometers or angstrom units. In this way, side length, edge of the length edge length is to be given. After that, anyone is to be asked by supplying other remaining terms. So this is the formula which is useful in this chapter to calculate any one of the variables in the available one. Therefore, Z is a number of particles in unit cell. Next, A is edge length. Na, Avogadro number. M, molar mass, that is expressed in gram per mole. Na, Avogadro's number. Its value is 6.022 into 10 to the power 23 number of particles. Now we are going to solve few problems based on this area. Observe, my dear students, we have to solve some questions regarding density of the unit cell. Right, an element with molar mass 2.7 into 10 to the power minus 2 kilogram per mole forms a cubic unit cell with edge length 405 picometers. If its density is 2.7 into 10 to the power 3 kilogram per meter cube, what is the nature of the cubic unit cell? The first one is data collection. Right, what is given? Molar mass is given, capital M, 2.7 into 10 to the power minus 2 kilogram per mole. Next, edge length. Edge length is denoted by A. 405 picometers should be converted, in which case it is SI units, it is in meters. So 405 into 10 to the power minus 12 meters. Next, density is given. Density is equal to 2.7 into 10 cube. And what is the nature? Nature of the cubic unit cell is identified with the help of Z value. If Z is 1, simple cubic. If Z is 2, that is a body-centered cubic unit cell. And if Z is 4, that is face-centered or cubic closed packing. CCP unit cell. So Z is question mark, formula 1 mark. So density, if it is a board examination, density is equal to, or directly Z is equal to, how we take the Z is equal to density into Avogadro number into A cube over molar mass. Substitution, simplification, final answer with units. Density is 2.7 into 10 to the power 3 kilogram per meter cube into Na 6.022 into 10 to the power 23. A 405 is 405 into 10 to the power minus 12 whole cube over upon molar mass is 2.7 into 10 to the power minus 2. After simplification, what is the answer? You try yourself and then get the answer. Now, Z is nearly 4 after calculation. So, 4 is a type that is FCC or CCP is the answer. Next problem will be taken. Get ready. Observe this problem. Silver aging crystallizes in FCC lattice if edge length of the unit cell is 4.07 into 10 to the power of minus 8 centimeters and density is 10.5 gram per centimeter cube. Calculate the atomic mass of silver. Atomic mass of silver, question mark. Next, density is given, that is 10.5 gram per centimeter cube. Next, edge length is given, that is A, that is 4.07 into 10 to the power minus 8 in centimeters. And the type of unit cell is FCC. For FCC, Z value is 4. This is the knowledge of the student to recall the information from the previous lesson. Now the formula, what is to be calculated? Mass. And Avogadro number Na is in our hands, that is 6.00022 into 10 raised 23. No units to that one. Come to formula M. M is equal to, as usual, density into Avogadro number into A cube over number of particles. Substitution, simplification. Density 10.5 into Na 6.022 into 10 raised 23 into A, and edge length 4.07 into 10 to the power minus 8 whole cube over number of particles Z 4. This is the knowledge of the student. Yes, you have knowledge, no problem. After simplification, answer is 106.57 grams per mole. Of course, silver name is given, it is near to 108 and the answer here available is 107, no problem at all. Look into this problem, dear students. Niobium, Nb is a symbol, crystallizes in body-centered cubic unit cell structure if the density is 8.55 gram per centimeter cube. Calculate atomic radius of niobium using its atomic mass 93U. Yes, atomic mass data collection, yes, that is M is 93U, that is unified mass is converted to, this is a 1 atom weight. Avogadro number of particles weight is also 93 gram per mole. Means this is a 1 atom weight. Avogadro number, this unified mass is changed to 1 unified mass is equal to 1.66 into 10 raised minus 24 grams. Unified mass into grams. That into Avogadro number, you will get near the same value, easy calculation. Next, atomic radius is not immediately identified, that is in the form of A. A-R relation is there. So from that one, first A is to be calculated, question mark. After calculation of A, we are going to calculate radius. Then density is given, dear students, 8.55 into 10 to the power, 8.55 gram per centimeter cube, cubic centimeter, and BCC indicates total number of particles per unit cell is 2. 8 coordinates into 1 by 8. After contribution or sharing 1 plus 1 body center 2. This is your memory. Previously also discussed at the time of packing efficiency. Now Avogadro number is in our hands, 6.022 into 10 to the power 23 particles. Now the formula is A cube is equal to yes, M mass into Z by density into Na, or simply A is equal to cube root of the above one, mass into Z by D into Avogadro number. So next step is substitution. Square root of mass is 6093 as the number of particles 2 in BCC over upon D density 8.55 upon Na 6.022 into 10 raised 23. After simplification, the available answer is, you try yourself, dear students, 3.31 into 10 to the power minus 8. This is generally happened. Why? Because density is given in gram per centimeter cube and edge length is. So after edge length, what is the relation between A and this is primary step is over. First step, major step is over. Now radius is asked, dear student. So radius is obtained from A and the relation is 4R is equal to root 3A. Root 3 into A we studied. Now A is equal to, R is equal to root 3R, root 3 into A by 4. After substitution, root 3, 1.732, A value 3.31 into 10 to the power of minus 8 over 4. Then the final answer, it is very easy by you, that is 143 picometers. Here we are not going to explain in what way it is cancelled, all those things we have to do with calculator. If it is competitive question, then we have to do manually without any help of the device. Observe, my dear students, some of the index questions we are going to answer here. We are going to discuss and take the answer. What is two-dimensional coordination number of molecule in square closed packing? As square closed packing is two-dimensional square like this, dear students. Right. If you select this one, as how is this? These are the particles which are in contact with the selected particle. This is selected particle. With the selected particle, these are in contact. Answer is 4. Simple. If it is three-dimensional, that is 6. Now, a compound forms hexagonal closed pack. What is the total number of voids? As voids are largely two types, octahedral void and tetrahedral void. And if you take 0.5 mole of that compound, and how many of these are tetrahedral voids? Yes. In HCP, by other means of calculation, which is not given in NCERT, in HCP, yes, number of particles or atoms, molecules. Number of particles is 4. Calculation method is not given, but final answer is 4, like FCC. Next one is, if a system structure has n number of particles, same number of octahedral voids. Therefore, octahedral voids are. Therefore, octahedral voids are same number 4, based on the previous rule. Then tetrahedral voids, the relation is double the number of particles. Double the number of particles. Tetrahedral voids is 8. But here, how many was the total voids? Now, total voids are total number of voids. Total number of voids is equal to tetrahedral plus octahedral plus tetrahedral. 4 plus 8. Octahedral voids plus tetrahedral voids. 4 plus 8, that is 12. If it is 1 mole, therefore 1 mole has 1 mole of compound. 1 mole of compound has 12 total voids, and 0.5 moles of the compound has how many? Yes, 12 into 1 by 0.5. Sorry, 12 into 0.5 by 1, 6. You can reduce that one. Therefore, octahedral voids are 2 and tetrahedral voids are 4, total 6. I hope you followed this one. Other questions will be taken very soon. Look into this question, dear students. A compound is formed by two elements M and capital N. Capital N forms CCP, nothing but that is FCC. Next, atoms of M occupy 1/3 of tetrahedral voids. Now, how do we solve this one? So let us take N. Therefore, number of N atoms is 4. Why? Because 4, that is FCC. Already discussed. Next, therefore, then tetrahedral voids, possible voids of double the number of atoms, so that is equal to 4 into 2 or 2 into 4, 8. But all tetrahedral voids are not occupied, only few are occupied. How many? 1/3 occupied. Therefore, M is 8 into 1 by S, which are occupying. This is M. M is occupying. M 8 available, but 1/3 only occupied, and N 4. The formula next, that becomes M 8 by 3 and N 4. After LCM, 8 by 3, 4, LCM is 12, this becomes 8, and this becomes 4 into 3, 3 LCM, and 3 into 4, 12. So, this LCM is common both cases after multiplying. Then, answer is, this is one formula. Next one is R. M, how many number? M 8, N 12. Or further simplified, M 2, N 3. This is answer correct. This answer also correct. This, anyone. These two are empirical. This is empirical formula. This is a normal one. This is the molecular formula, like that. Answer is given. Look into this question, dear students. Which of the following lattices has the highest packing efficiency? Packing efficiency already we discussed. Simple cube, that is 52.4%, and body centered is 68%, and hexagonal is 74%. If you are remembering, after knowing these values, answer is hexagonal closed pack. If other is asked, HCP is equal to CCP is nothing but FCC greater than BCC greater than simple cube. This is useful for competitive point of view. Most effective packing efficiency is observed in which of the following? They may give least given. Least is simple cube and equal is SCP. CCP nothing but FCC. In a crystal, element A forms FCC and element B forms or occupy alternate tetrahedral voids. Very, very important, alternate tetrahedral voids. Next, what is the formula of the compound? This question is only exclusively useful for JEE, sometimes NEET or CET also. So JEE largely this question is going to be asked. Right, in FCC, means where are particles A present? Particles A present at two lattice points, that is at corner and face center. Okay, A is present on along corners and face centered. These are face centers, which I am not going to write. Front side, back side not written. Okay, front side is this one, back side is that one. They are looking some confusion to the student. That's why this is a removed. Leave it for understanding purpose. So, how many atoms are A? Therefore, per unit cell. Per unit cell, number of atoms of A is, as usual, FCC that is 4 calculation. Z we calculated how? 8 corners into 1 by 8, 1, 6 face centers into 1 by 2, 3. That 1 plus 3 is nothing but 4 is a direct information. Where is B occupying? B occupying alternate tetrahedral words. Where are tetrahedral words are located? Exactly from the corner. Exactly from the corner, 1/4 distance. Observe here. As if you observe, this is a corner. What I am showing, this is a corner. 1/4 distance top. At every corner. Observe your room where you are sitting. 1/4 of the corner. How many corners? 8 corners. So how many tetrahedral words? Double the number of particles. Already the particles are 4, and double the number is so therefore total number of tetrahedral voids is 8. How? That is 2 into 4. But alternate is there. Alternate means half of the tetrahedral voids. Alternate is nothing but half of the tetrahedral voids. Half of, that is very important. So only how many are participated? 4. Therefore, as B alternate tetrahedral voids, that is half of available one. So therefore 4. Hence the formula is A4 B4. If this option is not available, empirical formula, the simplest ratio of atoms of elements in the given compound is empirical formula. So AB. I hope you followed this one, and this is observed in case of a well-known compound, that is ZnS. It is known as zinc blend. Either zinc or sulfur occupies FCC, and other one occupies alternate tetrahedroids, and this is known as zinc blend structure. This is also known as zinc blend structure. Other things will be continued. In a crystal, element Q forms CCP, while element P occupy all the tetrahedral voids. What is the formula of the compound? So simple. Yes, Q forms CCP. CCP is nothing but, that is FCC. For FCC, number of particles 4. Already discussed in the previous one also. Then P occupies tetrahedral voids. How many tetrahedral voids if the particles are 4? Therefore, tetrahedral voids are 8. That is double the number, 2 into 4. Then formula of the compound is P 8 in number, Q 4 in number, that is P2 Q. Example is, in this case the example is Na2O. Na2O is known as anti-fluoride structure. Anti-fluoride structure means, yes, O forms, oxygen forms CCP, and anions, cation is occupying Na plus, occupying O2 minus forms CCP, Na plus, all tetrahedral voids. The formula is, and the compound is known as, compound has structure known as anti-fluoride structure. Reverse will be taken. Get ready. Observe students, in a crystal CaF2, calcium 2 plus ions forms, calcium ion forms cubic closed backing, that is FCC, while F minus ions occupy all the tetrahedral voids. What is the formula of the compound? As Ca2 plus CCP, that is equal to 4 particles. Next, F minus at tetrahedral voids, that is 2 into 4, 8. Therefore, formula of the compound is Ca4F8, nothing but empirical formula is CaF2, and it is known as fluoride structure. Fluoride structure. And if you observe reverse, cation FCC and anion all the tetrahedroids. Now Na2O CaF2. What is observed? Cation FCC, whereas anion all tetrahedral voids. In this case, cation all tetrahedral voids, anion FCC. So this structure is known as antifluoride Na2O, which is reversed to the fluoride structure. So CaF2 is also known as fluoride, that is fluorspar. CaF2 is known as fluorspar, and the structure in solid state is known as fluoride structure. Good luck.